Alrighty, so we talk about our toolkit of parent functions. These are our basic functions that we're going to work with, that we need to be able to understand how they behave and all the different things um, throughout calculus. It's just pulling all that algebra and stuff around for you guys. What does y equals x squared look like? It's a parabola, right? It's our U-shaped graph. What about x cubed? That's our sneaky snake. I found those old vines again this weekend, and I just died laughing. Anyway, what about square root x? It's not the v. That's absolute value. It's your stretch, right? Your stretch function is kind of what I call it. All right. What about cube root? Walk like an Egyptian. Yep. All right. So it's your sneaky snake turned on its side. 1 over x we talked about yesterday. It's that reciprocal function. What do you think that bottom one was? That's a semicircle. Okay.
Teachers at this time, sophomores, alphabet letter F through L. Sophomores, F through L. Report to the library this time from your iPad.
Okay. So those are just some of our basic functions that we got to be sure that we recognize them when we see them. Okay. And know how they behave. Right. There are some additional ones that kind of pop up in calculus that we've not talked about before, all right, that I want us to kind of look at today and kind of just look at their characteristics and what they look like. They're not hard to decipher on our own if we don't remember. I'm not asking you to memorize that, okay? But let's think about 1 over x squared. It looks a lot like that reciprocal function. But what do you think squaring it's going to do? On the bottom. If I plug a negative in there, what's it going to do to my fraction? Makes it positive, okay? So the first quadrant's going to look exactly like the reciprocal function, okay? But because it's squared, it's no longer going to be in the third quadrant. Guess where it goes? This second. It's going to flip back up to the second quadrant, all right? So it's a lot like your reciprocal function there, okay? Except y is going to always be positive, okay? So that one's kind of interesting. This next one, we start dealing with irrational exponents. So let's go back and kind of think through that again. If I have something to the 3/2 power, what are we doing? Yep, we're going to take the square root and then cube it. Okay, we're going to take the square root and then cube it. So if we're taking the square root, what's going to be true about the domain of that function? It's got to be positive, right? It's got to be positive or greater than or equal to 0. So if I plug in 0, I'm still going to get 0. Okay. If I plug in 1, what are we going to get? Square root of 1 is, we cube it, 1. Okay, so we're going to get 1, 1. I'm not going to put 2 in there. Why not? Yeah, there's no perfect square root of 2, right? So let's jump to 4. All right, what's the square root of 4? 2. And then if I cube it, 8. So it's just growing a lot quicker than your square root function. Okay, so it's just going to grow a lot quicker. All right. And the last one's probably my favorite because I love what it does. So to the 2/3, we're going to reverse that process. We're going to take a cube root and then we're going to square it. Okay, so if I'm taking a cube root, can x be negative? You had a 50-50 shot, right? And it is, yes, okay? So, yeah, because the cube root of -1 is -1, right? So we can do positives and negatives this time. So if I take the cube root of 0, it's 0, and I square it, it's 0, right? If I do the cube root of 1 and I square it, it's 1, all right? If I do what would be the next best cube root? 8, okay? So we're going to jump out a little bit. If I take the cube root of 8, I get what? 2. I square it, I get 4. So it's going to do this on the positive side. Now let's think through the negative side. If I put negative 1 in, cube root of negative 1 is negative 1. I square it, I get positive 1. Okay? If I put if I do negative 8, cube root of negative 8, negative 2 squared, I get positive 4, right? So I like to call this a bird function because that's how I used to draw my birds when I was a little girl, you know, in my picture. You know what I'm talking about? Like V's. So I like to refer to it as a bird. So anyway. All right. Okay. So if I say give me the bird, no. All right. I'm just kidding. All right. This is what I'm talking about. Okay. So our 2/3 looks like a bird. Right? So just some new functions, parent toolkits. Now, does trig fit into that? Yep, it sure does, but we're going to do that on Monday. Okay? We'll kind of give them their own little place. So just some basic functions that you will see over and over and over again in calculus, things that we got to think about, domain and range, that are unique in terms of how they're found. Okay? All right. So let's talk about transformations. Okay, transformations. If we want to move a graph around, do all the things. If I do a function and I add or subtract a number at the end, how does that move it? Up or down? Okay. If I add or subtract a number inside with x, left and right, okay? And remember, that's an opposite, okay? Whatever's in there, we do the opposite, right? What if we put a number out in front? It stretches the y values, okay? It's going to change y. What if we put that number inside? It changes x. And remember, this is the one where you divide x. Okay? Almost everything else that's a factor is a multiple, but this is where we would actually divide it. Okay? What does this do? If I put absolute value around it. It makes all y values that are negative positive. It flips it over the x-axis. Good. Okay. What's another one we did? Oh, if we have a negative in front, what does that do? Just flips it upside down. Yeah, it's a reflection. Good. Okay, it's a reflection over x. So all the different transformations that we might have to a function. Okay. Understanding how functions behave is going to be so critical when we get into things like extrema, concavity, all that kind of stuff, right? We kind of got briefly into that last year in pre-cal. But we'll really, really dig into that and do all the calculus behind all of that this year. So understanding how our functions work is important. All right, so let's take a look at one. Here's one that's got it all. All right, just for fun. All right, let's see if we can graph that one. All right, take a second, play with it. Are you inside that parenthesis before we start? Yeah, there's a factor in there. Let's factor inside that parenthesis. Okay, so there's your minutes. Factor inside that parenthesis. I like your shoes, Oakley. I like your shoes.
Thank you.
I just don't think they're comfortable. No, I have a pair and they're so uncomfortable. I can only wear them when I'm sitting down. Like for real, for real. Y'all, I get so tickled. I think people's feet are hurt, like their legs are hurt when I see them walk down the hall, but they're just trying not to crease their shoes. And I laugh so hard. This one kid was literally running to the bathroom, but like, I was like, that's funny. All right, lots of transformations in this one equation, right? We put it all in there together to see what we could do. Let's kind of talk through. First of all, who's your parent function? What shape is this going to be? It's a quadratic, okay? It's y equals x squared. Let's talk about where we're going to move it to, all right? We're going to move it left or right. We're going to move it right to up or down? Up 3, okay? So I'm going to do that first, just so I know where I'm going to start my graph. So right 2 and up 1, 2, 3, and I'm just going to kind of make a little X right there so that I know I'm going to graph from that point right there, all right? Now, the thing about the other stuff that's left, I think about that basic table of ordered pairs for a quadratic. Okay, you don't have to write that part down, but that's what I think about. That's my y equals x squared ordered pairs, okay? The -2 in the front is going to change all of the y's, okay? So my y's are going to be -8, -2, -2, -8, all right? My x's, we're going to change by the number that's inside. We're going to divide those by 2. Okay, so I'd get a -1, a -1/2, a 1/2, and a 1. And I'm going to graph those ordered pairs from that blue X. Okay, so I would go left 1 and down 8. 1, 2, 3, 4, 5, 6, 7, 8. Left a half and down 2. That's not quite as easy to graph. Luckily, 0, 0 gets to stay. And then I'm just going to repeat that on the other side. All right, and so my picture should be this real scrawny parabola, all right, in the end. All right, so just working through all of our different transformations. Always start with that left-right shift, then deal with anything that's a factor. They're shrinking and stretching, okay? It looks like x minus 2. I don't like that. Let's do that. Okay. All right. So question about transformations. Just spend a minute. Okay. I saved some of y'all's posters and put them around. I'll try to change a few of them out every year, just so I don't forget. Okay. What did you do, Jawak? I forgot. I'll never forget Justin's. All right.
The title of it was Band Functions.
Oh, that's right. That's right.
What was Justin?
Justin's was SpongeBob and
Oh, yeah. the
Patrick
past-
and
Yeah.
fishnets. That was very creative. Okay.
Almost got it. At least something.
All right. Question about that? Transformations. Is that the end of that page? Yes. Okay. Oh, you got, what is that? Fake money?
Oh, yeah. I was counting
Oh my
$10.
goodness.
Your van dollars.
You only have one?
You have $1 million?
I was gonna give it to him.
No, never invest.
What can you buy with those?
Nothing now. But last year you could buy like a lot of stuff.
Oh.
Like extra days on assignments and extra funds.
Oh. How'd you get it?
I don't know.
Being good?
Just
Being the
well.
process.
Yeah, doing well on tests.
Okay, cool. Him while making you a shirt.
When he's feeling generous.
I remember getting 5 from doing a solo.
A solo?
Yeah, like I had to sing a solo.
Karaoke.
Oh.
We were doing an ID quiz and it turned into him.
Was, yeah, wasn't it the Funko?
Okay.
Yeah.
You should make like
I'll come up with something.
yeah.
We need our own economy is what you're telling me. Okay. Alrighty. So let's jump in here and look at a little bit more algebra. Even and odd functions. Okay. Even and odd functions. AP is very specific about how they will accept even and odd functions. It's almost always algebraic in proof. In pre-cal, we got the privilege of being able to look at it graphically. But remember, even functions graphically look something like this. They're symmetric about the y-axis. So if you have the point x, y, you also have the point negative x, y. Okay? Algebraically, remember we would write that f of negative x equals f of x. If I plug in a negative number, a negative x, everywhere in my equation, I should get the original back. Okay, so an even function, symmetric about the y-axis. Right. An odd function, remember, is symmetric about the origin. All right, they are in diagonal quadrants. If I plug in a negative number, I should get the opposite of the function. All the signs should change. Okay, and so my ordered pairs change to x comma y, negative x, negative y. Okay, everything changes. Y'all, I owe Becca like $1 million over these toys. Like, I just can't tell you. There's a little girl in my third block. I say little girl, she's grown, like y'all. But anyway, and she was like, I'm going to need, in her information sheet, she's like, I'm going to need a whole basket of the stars. And I was like, okay, I'll see what I can do. Like, whatever it takes, right? Okay. All right, so let's just do a little bit of this algebraically. So it says to determine if the function's even, odd, or neither. Not all functions have those characteristics. So algebraically, if I'm going to do x plus 1, if I plug in a negative x, that gives me a negative x plus 1. I just, everywhere I have an x, I put a negative x, right? If we simplify that, we'd get negative x plus 1. And now we ask ourselves 2 questions. Did it all stay the same, or did it all change? Okay, from the original, you're referencing the original. Is this exactly the same, or did it all change? It's neither, right? The only thing that changed was that x value. So this one actually does not have even or odd symmetry.
I blame the process.
Okay, it's neither.
At this time, we need sophomores, last name M through R, sophomores, report to the library at this time for your iPad.
Okay, so if we do it again on the second one, we're going to plug in a negative x, and let's see what happens. Right? If I take a negative x and I square it, what will I get? Positive x squared plus 1. And so now we compare. Did I get it to be exactly the same as the original, or did everything change? It's all the same, so it's even. Okay, so that is the justification for even and odd. That should help you on that Twiz I gave you yesterday. All right.
We're supposed to be doing that right now. Like,
That's your assignment. It's due on Tuesday.
oh,
Yeah, it's due Tuesday.
good to know.
I'm going to reiterate that here in a little bit, but it is due on Tuesday. Okay? So even if odd. All right, now, piecewise functions. Y'all, people love to hate on piecewise functions, but let me just tell you, everything we do, we will do for a piecewise function. All right? Minus an integral. Okay? We typically don't integrate a piecewise function, but we'll do derivatives of piecewise functions. We'll do all kinds of stuff with piecewise functions, all right? Piecewise just means it's a bunch of pieces over a specified domain. So it's multiple functions over a specified domain. Okay. Being able to graph one will help you tremendously, all right? And so that's what I want us to look at today, is graphing a piecewise. I can't remember if that's on the Twiz or not, but I think it is. All right. So I like to address these a little bit at a time. We have to look at those domain restrictions. The greater thans, the less thans, the equal tos, they're important because they tell me, do I need open circles? Do I need closed circles? Which x values are we going to consider? And so if we look at the first piece, the function is f of x equals negative x. What is negative x when I graph it? What kind of function? It's a linear and it has negative slope, correct? Okay, so it's a line with negative slope of 1 over 1, but we want the pieces that are less than 0. So if I'm less than 0, what would negative x be at 0? It'd be 0. So we're going to have an open circle at 0. Okay, so we're going to have an open circle at 0. So this is linear. We know it has a slope of negative 1, so we're going to go to the left, plot a few points. And there's that piece, okay? It's that linear function, slope of negative 1. It continues forever, all right? Bless you. Already allergic to calculus. Sierra's allergic to calculus. Y'all are going to have to encourage Sierra. She's trying to jump ship. We got to lift her up. I won't hate you if you leave, but I don't want you to leave. Okay. All right. Because you're wildly capable. Just saying.
That's one of our affirmations.
It is. You're wildly capable. Okay. The next piece, the middle piece, all right, is x squared. What's it going to be? It's quadratic. You need to remember that. Okay, when you get ready to graph it. Interesting thing there is that 0 is included, as is 1. Okay, so all I have to do is really plug in those two endpoints. 0 squared is 0, so it's going to color in that dot that we left open. 1 squared is 1, so it's important to remember that piece is not linear, so it's got to have this little bit of curve to it. It's hard to see because it's tiny, all right, but it's got a little bit of curve to it. All right, and then our last piece is y equals 1. What would that look like? It's a horizontal line, y equals 1. right? So it would go across, so it's just a line. So at 1, y is 1. Well, I've already colored in that dot, even though it says this one is closed, so I'm just going to extend it out. And there's my function. Okay, so I've got two linear pieces of that little bitty piece of a curve in there. Okay, it's still a function graphically, all right? Does it pass the vertical line test? Yep, sure does. Okay, so there's our function. What would the domain be of that function? Yep, it's everybody. All the x's are good, negative infinity to positive infinity. What about the range? Yep, it would be 0. Would we include 0? Yes. 0 to positive infinity. Everything is up above that x-axis. Okay. All right, absolute value, okay? Graphically, that function, that's cheerleader arms, right? It's our V. Okay? It's our cheerleader arms, but I want to talk about the definition of absolute value. Absolute value is actually defined as a piecewise function, okay? So y equal to absolute value of x, right? As long as x is positive, then absolute value of x is also positive, okay? We know that. If I put a positive number in there, I get a positive number out. I get the exact same number back out, okay? What happens when x is less than 0? When I put a negative number in there? I get a positive number back out. So how do I change a negative number to a positive number? I multiply it by -1. Okay? So if I put a negative number in there, I don't get that negative number back out. I get the opposite of it. So that's why we say negative x. Okay? We will use that definition a lot to be able to take derivatives and do integrals and things like that. Okay? Knowing which piece of the absolute value we're dealing with, the positive piece or the negative piece. I love absolute value. He's kind of cool. Did you get them all in? No? Okay. So goals.
It's gotta happen soon.
There's not enough, there's too much air in
Yeah.
Poke a hole in it and you'll get all that green one over there.
it. I'll poke a hole in you.
You think the green one can happen?
It's just
Y'all,
like
after
stab
third
me in
block
school.
yesterday, at the end of the lesson, I looked around and they were stuck all over the board. I was like, golly. It was funny though. They put them back down. All right, let's do a composition of functions. Function operations are not bad. We add, we subtract, we multiply, we divide. But composition is that two-step process. Remember, it can look one of two ways. F of g of x, or we could use that fog notation where it's the open circle. Okay. We start and we work our way from the inside out.
Oh, I like these.
Yeah, I do too. Okay. This is a two-step process. Remember, we start here and then evaluate in the outside function.
What does fog mean?
Same thing. Means f of g of x, but you'll see that notation used interchangeably. I think AP likes the parenthesis notation better than the fog notation, but just want you to see both. You can see it both ways in your calc books later on. So. Okay. Is the example on the next page? Yeah. Okay. All right, we got two more, y'all. We're about done. All right, so let's do these two. Okay. Look at 19. Take f of x equal to x minus 7 and g of x equal to x squared. Let's do f of g of 2, and then let's get fun, and let's do f of g of x plus 2. Take a second to do that. Do y'all like the tables and chairs better than the desks? Me too.
It's like my legs are breathing.
Oh, gotta remember. We're gonna go back through it all on Monday. You'll put it off.
Don't.
I mean,
don't.
X squared
What
plus
do you
four.
mean? Something.
Right, because I forgot.
Well, one of us
No, I know.
is right.
Yeah, one of us asked.
I don't. It's why.
But why? There's always something going on. Oh wait, no, I messed this up. I see my mistakes. Yeah, I think I messed it too. Hey, I don't know. Open the hole by myself. Not home down.
All right, did we get -3 for the first one?
Yes.
Yes, I did it right. Praise the Lord. It's a good day. Okay. What about the next one? All right. Just remember that everywhere, okay, in G that we have an X, we're going to put X plus 2. Okay. So I'm really doing F of X plus 2.
Sophomores, your alphabet letter S through Z. Come to the library this time. Be sure you have your pink paperwork for your iPad. Sophomores, S through Z. Report to the library this time.
All right, so X plus 2. All right, and we're going to square it. Now I'm going to take that expression and everywhere in F that I have an X, I'm going to put that instead. So I have X plus 2 squared and then minus 7. If we multiply that out, all right, that's X plus 2 times X plus 2. And then I'm going to subtract 7. So that would give me X squared plus 4X plus 4 minus 7, which would, in the end, give me X squared plus 4X minus 3. Okay, so just some good algebra. When I tell you algebra is what's going to get you in calculus, it happens every time. All right, your algebra skills will improve just because you're going to use them so much. Okay, where'd you goof at, Jawak?
The X plus 2 squared.
Yeah.
That's where
Did you put X squared plus 4?
No, instead of the 2 there, I put X squared for X.
Oh, gotcha. All right. That'll mess you up just a little. Okay. So decomposing functions, if we can put them together, we can take them apart. Okay. So if we know that a function h is equal to f of g of x, remember we find g of x is our inside function. Okay, usually it's in parentheses, under a radical. Okay, in a denominator, that's usually our inside function, okay? F of x is what we do to that. Okay, so f of x is what we do to that function, all right? Did I take that thing and I squared it? Did I throw it in a denominator? Did I put it under a square root? What did I do to it? Okay. So we're just breaking it apart. Decompose, break it apart. Okay. Y'all remember my joke? What's Beethoven busy doing? Decomposing. Okay. Listen, in my family group chat, we send bad dad jokes all the time. It's awesome. Sometimes I really, really laugh. I'll go back and give you some of the highlights of summer here in a little bit. Okay. Did I do it last year too? Okay. I like a bad dad joke. They make me smile. All right, so let's look at this example. Let's see if we can break it apart. There's my composed function. We want to find, what did we put inside? And then what did we do to that inside? Okay, what would you think might be my inside function? X minus 5 is what I would put. Okay, and then what did we do to it? Well, we put it in a denominator and we raised it to the 5th power. Okay, we keep the variables the same, and that's what's kind of weird for people. All right, because if we think we did the same thing at the one at the top, but it's just harder to see when we go backwards. Okay, could you have also done g of x is equal to x minus 5 to the 5th, and then f of x would just be 3 over that? Okay, both of those are 100% correct, right? One of the things we're going to find about integrating and taking derivatives is that there's always a best decomposition, all right? And so although both work, one would cause us to work harder to get the correct answer, okay? So question about decomposition. Is the first one what?
The first one better one?
It is. Yeah, the first one actually is the better one. Okay. All right. So that was your first set of helpful hints to help you with that TWIS, okay? That's why we've kind of going back through some things, because I just want to see how you process through that information. Like I said, I'm going to take it from you. You will not get a grade for it, but I will give you some really good, solid feedback on it, okay? So they take me a little while to get back to you. Luckily, there's just 14 of you, so that won't hopefully take forever, all right? So your lesson practice is that Chapter 1 TWIS. On Monday, we're going to talk about all things trig. All right, so just to bring all of that back up, Tuesday. On Monday, we're going to talk about all things trig, to kind of bring all of that back up to the forefront of your brain, okay? So just to give you some ideas, I would start working on it. There may be some things in there that you can't remember, and that's okay. Just try, all right? Just try. One of the things that you'll always find about the AP test and my test in particular is there's going to always be a question that's a little bit different than anything we've done in class. There's always one or two, okay? Because they're going to do that to you on the AP exam, all right? You might get parts of those questions, but you might not get it all. One thing that is different is on test corrections, okay? We'll have a day in class, like we always do. We take the test one day, the next day you get to do corrections in class. 80% back, all right? You can also come in after that 80% if you still have things you haven't gotten correct yet on your own time, and you can get 50% back for those, okay? That's on purpose. The tests are hard, okay? So they're hard, but those opportunities, because your testing should be a learning opportunity as well, all right, in my opinion. So I'm not out to try to punish you. I'm trying to help you get ready for May, all right? So That's my goal with that, all right? Quizzes are the same as before. If you make less than a 60, you can retake those to make up to a 60, all right? And for a lot, they make a difference. Doing that makes a difference, y'all. So you may say it's only 3 points, but there might come a time where you need those 3 points, you know? So always take advantage of that opportunity. Okay, so that's it for the lesson today. We're going to do a little activity next. Kind of a puzzle. I like a puzzle. I don't know about y'all. Let me see if I can.